Hello friends, welcome to the session on digital image processing. In this session, we will be discuss about what we mean by intensity transformation in the digital images. In this session, we will see how to define the intensity transformations, what are the different functions available to perform the intensity transformations on the digital images. Also, we will see what we mean by image histogram and the histogram equalization. Friends, as you know that you are viewing this session on my YouTube channel, and you can subscribe to the channel so that you can watch many other educational videos on the various topics of the subjects of electronics and computer science. So let us start the session with the question what we mean by digital image. So as already we know that whenever we think of any digital image, then this digital image can be described by using a function f of x comma y, where x and y are called as the spatial coordinates or plane coordinates. So the function will return the intensity value, and the image is basically consisting of large number of collection of pixel, where every pixel will have a certain intensity value. And this intensity value can be described by using the function f of x comma y. So this function can be described by using the matrix, and the matrix values will give the intensity values at the different positions of the pixel. So the elements are referred as the picture elements, or they are referred as the pales or pixels. So pixel is the most widely used term to denote the elements of the digital image. So as shown in this window, the image is just nothing but the collection of dots or pixel. Every pixel will have certain intensity value, and this intensity value can be given by this function, and all such values can be described by using a table or a matrix. Now let us understand what we mean by intensity transformation. Whenever we have digital image, then it is necessary that we can perform several operations on this digital image. So whenever we manipulate the contrast of the image, then such manipulation on the contrast of the image is being called as the intensity transformation. So in the spatial domain, it is possible that we can perform these operations directly on the pixels of the image. So whenever we think of any pixel of the image, then you will find that we can describe the neighborhood of the pixel. So neighborhood of the pixel is just nothing but a collection of nearby pixel to the concerned pixel. And whenever we want to describe the process on this pixel, then this process can be given by a function t of f of x comma y. So we write it as g of x comma y is equal to t of f of x comma y, where f of x comma y is an input image, g of x comma y is an output image, and t is just nothing but an operator, intensity operator, which will perform certain operation on the image. So intensity transformation functions can be written as s is equal to t of r, where r is the intensity of the image f, and s is the intensity of the output image g, and both will denote the intensity at the point x comma y in the image. So whenever you have been given any image, then it is possible that you can process this image and you can perform some intensity transformation on the image by the various functions that are provided in MATLAB or Scilab. The most popular function that can be used with the image is the function image adjust. So the syntax for this function is like this: g is equal to im adjust the function f or the image f. Then in the square bracket, we can have a lower value and higher value, comma, lower value and higher value, comma, value of the gamma. So for example, we can write g1 is equal to image adjust f of 0, 1 and 1, 0. So for example, if I write such type of the function in the Scilab, and suppose I read my input image as the image of the dog, then you will find that when you process this statement in the Scilab, then you will obtain the image as shown in this window. So one can easily observe that actually what we are doing is that we are getting the photographic negative of the image. If I write this function G2 is equal to image adjust F, and if I left this low and high value to the default values, and if I mention the value of gamma is equal to 2, then you will find that the intensity distribution of the image will get changed, and you will find that the original image will be converted into such form of the image. If I write the function as G3 is equal to image adjust F of 0.5, 0.75, 0, 1, then in that case, you will find that a more contrast or a dark image will be observed compared to that of original input image. It is possible that we can get the total possible intensity levels in the image. And when we plot the total possible intensity level in an image, then that is being called as an image histogram. An image histogram can be described by a function h is equal to IM_hist in the bracket f comma b, where f is the input image, h is the histogram of the image, and b is the number of the bins that are being used in the histogram. So by default, the value of the b can be 256. And we can make the use of the function SCF to set the current graphic. So for example, if I make the use of the function SCF0 IM_hist f comma 10 comma 0.5, then you will find that I will get the histogram of the image. So on the y-axis, there are different number of values, and on the x-axis, you will find that the number of gray levels. So any particular gray level, how many times it will appear in the image will be described by using this histogram. So histogram function in the Scilab can be written by making the use of the syntax counts comma cells is equal to IM_hist. And in the bracket, you can make the use of the image. So you'll find that IM is an image which can be Boolean or unit 8, or it can be double or unit 16 image. Bins, that is the number of bins that are being used in the histogram. By default, you will find it will have certain value. Say, for example, it will have value 2 for Boolean, 2 raised to 8 for unit 8, and 2 raised to 16 for unit 16. So as you go on increasing the value of the bins, then you will find that the huge computer memory will be required for storing of the histogram. The width is then argument which is sent as a bar function, and you will find that it will define the width as a percentage of the available room for the bar. Color, that is the bar color, can be specified. By default, the color is the blue, but if you want to change the color, then it is possible that you can change the color. The count will return the histogram, and the cells will set the intervals for the bin. For example, if I write the function as a CF1 imagist f comma 10 comma 0.8, and if I set the color as green, then you will find that for the given image, the histogram bar will be displayed in the form of a green color. Histogram equalization is a very important process, and this process is being carried whenever we want to have a better adjustment of intensities in the image. So if you want to have a better distribution of the intensities in the image, then in that case, we can make the use of histogram equalization. So it will increase the global contrast of images. And this is useful when the data, the usable data of the image is represented by the close contrast values. So through this adjustment, the intensities can be better distributed on the histogram. So we can make the use of the histogram equalization function, and this histogram equalization function is to be written as y is equal to IM_hist equal. So in Scilab, this histogram equalization can be written by using this function IM_hist equal, where f is the input image and y is the output image, and where you will find that we can have an enhanced contrast of the images. For example, if I read my image and if I convert it into gray, and then if I show the original image, and then if I apply the histogram equalization function on this image, then the output will be displayed as shown in this window. So one can easily find that the intensity distribution or the contrast distribution in the image is much better when we apply the histogram equalization function. So thank you friends for viewing the session. Hopefully you have understood how to perform intensity transformations on the images. Thank you all.